everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we will be discussing some definitions and terminology related to the Module 4, which is Minimization of Boolean function. So, minimization of Boolean function includes various K-map and tabular method, and also we'll be discussing some of the definitions related to the combinational logic circuit. So what is parallel adder? So parallel adder is an arithmetic combinational logic circuit that is used to add more than one bit of data simultaneously. So the full adder can add only 3 bits of data at a time, but if you want to add two binary numbers of more than 1 bit each, then we have to go for parallel adder. So we can define the parallel adder as a combinational logic circuit that can be used to add two numbers of more than 1 bit simultaneously or else parallelly. Coming to the 5-variable K-map, define 5-variable K-map. So how can we define a 5-variable K-map? The number of cells in a 5-variable K-map, or else we can define the 5-variable K-map as the K-map which is used to simplify a 5-variable Boolean function is known as 5-variable K-map. So, and the 5-variable K-map will have total 32 cells, which is equals to 2 power 5. So, each of this cell will be representing any one of the input combinations, 32 input combinations. So as we have 5-variable Boolean function, right? So for a 5-variable Boolean function, what are the input combination that we can have? 2 power 5, 32. So those 32 combinations 0, 0, 0, 0, 2, 1, 1, 1, 1, 1, right? So these are the 32 combinations. So each of the cell will be representing any one of the input combination. So here and there are two possibilities of grouping 16 adjacent minterms, and also there are various possibilities for grouping 2 adjacent cells and 4 adjacent cells and even 8 adjacent cells like that. So that is about the 5-variable K-map, and simply we can define a 5-variable K-map as the K-map which is used to simplify a 5-variable Boolean function which consists of 32 cells, each of which represents any one of the 32 possible input combinations of a 5-variable Boolean function. So that is how we can define a 5-variable K-map. Now let us see 4-variable K-map. Define 4-variable K-map. So 4-variable K-map is a K-map which is used to simplify a 4-variable Boolean function. As a 4-variable Boolean function will have 16 possible combinations for input. So 4-variable K-map will be consisting of 16 cells, each of which is used to represent any one of the input combination of 4 variables, 4 input variables. So that is a 4-variable K-map, and it will be better if you give the K-map structure also for this one. So this is the K-map structure for 4-variable 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And this cell represents M0, M1, M3, M2. And this cell represents M4, M5, M7, M6. And this cell M8, M9, M10, M11. And this cell M13, M14, M12, M13, M15 and M14. So this is the K-map. So 4-variable K-map is defined as a K-map which is used to simplify a 4-variable Boolean function which consists of 16 cells, and each cell represents any one of the 16 possible combinations for 4 input variables. Define a 3-variable K-map. So 3-variable K-map is a K-map which is used to simplify a 3-variable Boolean function, and this 3-variable K-map will have 8 cells because As this Boolean function is 3 variable, so the number of possible input combinations are equals to 2 power 3, which is 8. So that is why a 3 variable K-map includes 8 cells. Each cell represents any one of the 8 possible input combinations. So this is a 3 variable K-map structure: 0, 1, 1, 1, 1, 0 and 0, 1. We have 4 columns and 2 rows, and the 2 columns represents a variable A is 0 and A is 1, and 4 columns represents the 4 possible combinations for B, C. And each cell represents, this cell represents M0, M1, M3, M2, whereas this one M4, M5, M7, M6. So this is a 3 variable K-map which is used to simplify the 3 variable Boolean function. Now define hazard. What is a hazard? Hazard is nothing but the dynamic hazard is a possibility of an output changing more than once as a result of single input change. Or else we can also define the hazard as unwanted transients present in the output with respect to the changes in the input state is known as hazard, which leads to the malfunctioning of the circuit. So that means hazard can be defined as a unwanted transients that can be happening in the output with respect to the changes in the input variables. So we have again 2 types of hazards here. What is static hazard? So the static hazard takes place when change in input causes the output to change momentarily before stabilizing its output. So here, actually the output has to remain either at logic 0 or logic 1, but the change in the input causes the output to change momentarily and comes back to its original position. Such type of hazard is known as static hazard. So these are the types of static hazard. So here this is 0, 0 and this is 1. So actually the output has to remain 0 even for the changes in the input, but momentarily it is going to logic 1 and again it is coming back to logic 0. So this type of static hazard is called as static 0. Actually it has to stay in logic 0 state, but momentarily it is going to logic 1 and coming back. And even we can have one more type of hazard, static hazard. This is another type of hazard, 0, 1. So this type of hazard is known as static 1 hazard. So what is this one actually? So even for the changes in the input, the output has to remain in the logic 1 state, but momentarily it is going to logic 0. So this is called as static 0 and static 1 hazard. Coming to the dynamic hazard, how can we define the dynamic hazard? Dynamic hazard is a possibility of an output changing more than once as a result of single input change. For a single input change, if the output changes more than once, then there exists an hazard which is known as dynamic hazard. So the dynamic hazards often occur in larger circuits where there are different routes to the outputs. That means there are various paths to output. In such cases, we'll have dynamic hazard where the output changes more than once for a single change in the input value. So this is dynamic hazard. Now, what is select line? So select line is the basic control signal in a multiplexer. So a multiplexer is a device that selects one of the several analog or digital input signals and forwards that selected input to a single line. And the multiplexer of 2 pair is multiplexer of 2 pair and inputs has n selection lines which are used to select any one of the 2 pair and inputs and will be directed to the single output. So that means we can say that select lines are the control inputs of a multiplexer based on which any one of the 2 pair and input lines will be selected and it will be transferred to the single output line of a multiplexer. So this is the basic definition of select line. We define data selector. So data selector takes one data input and a number of selection inputs, and they have several outputs. They forward the data input to one of the output depending on the value of selection inputs. So depending on the selection inputs, any one of the data is going to be selected and that will be sent to the output. So that kind of circuits are known as data selectors. And define decoder. What is a decoder? So decoder is a combinational logic circuit that changes a code into a set of signals. So it is called as decoder because it does the reverse operation of encoder. But we will begin our study with encoders and decoders. With decoders because they are simpler to design. So here we can say that decoder is a circuit which performs the reverse operation of encoder, where it converts the given binary data into decimal data, whereas the encoder converts the decimal data into binary data. It encodes the data into some secret form, that is nothing but encoder. Whereas the secret form of data is decoded here. What is the secret form of data? Binary data. So we can say that some of the binary data is going to be converted into decimal data. So we can say that decoder is a combinational circuit which changes the binary data into decimal data and whose size is given by n by 2 power n. So that is example of these decoders or 2 to 4 decoder and 3 to 8 decoder and so on. So where n input lines and 2 power n output lines. So this is a decoder circuit. Now define an encoder. So encoder is a combinational circuit which converts the given decimal data into binary data. So the n output lines generate binary code for the possible 2 power n input lines. So that means as it is converting the given decimal data into binary data, so that means we have n inputs and 2 power n outputs. So that means we can define an encoder as a combinational circuit which converts the given decimal data into its binary data, and where sorry, this is 2 power n inputs and n outputs. 2 power n inputs, n outputs. So that is the logic circuit for this is given by this one and so on. N in 2 power n inputs, whereas n outputs we have. It's a given binary data, decimal data is going to be converted into decimal data. Sorry, binary data. So encoder is a combinational logic circuit which converts the given decimal data into binary data and whose size is given by 2 power n by n, where 2 power n is the number of input lines and n is the number of output lines. So this is the encoder. Now define a priority encoder. So priority encoder is nothing but an encoder circuit in which the each input line, each of 2 power n input lines will be given priority, and based on that priority any one of the input line will be encoded into binary form. So the line which is having highest priority will be converted into binary first, and then the next lines are going to be converted into binary. So encoder is a combinational circuit which converts the given decimal data into binary data. Which data is to be converted into binary first? So each input line is given a priority, and that type of encoder is called as priority encoder. The input line which is having highest priority will be converted into binary first, and then the next higher priority line will be converted into binary. So that is priority encoder. Now coming to the enable input. What is enable input? So enable pin in multiplexer, demultiplexer, decoder and encoder ensures that the functioning of hardware, that is enables the function of logic circuit. So enable input is an extra input or else extra control signal which is given to the combinational logic circuit such as multiplexer, demultiplexer, encoder and decoder, such that the functioning of the hardware is enabled. That means the circuit is enabled, then it can perform its operation. Now coming to the K-map, define K-map. K-map is a graphical method of simplifying the Boolean function. K-map is nothing but graphical method of simplifying the Boolean function, which was introduced by the scientist named Karnaugh. And this method is known as Karnaugh map method or K-map method, which is a graphical method in which it contains two parent cells where n stands n is nothing but the number of variables of a given Boolean function. So we can define the K-map as graphical method of simplifying the Boolean function, which was introduced by the scientist named Karnaugh, and hence we can also call it as Karnaugh map method, which includes two parent cells where n is the number of variables in the given function. Define prime implicants and essential prime implicants. What do you mean by prime implicant and essential prime implicant? So the prime implicants are the product or sum terms written for each of the group formed in a K-map. So the product or, so first once we have drawn the K-map, we will be grouping the adjacent cells, and for each group the product or sum term is developed, and such type of product or sum terms are called as prime implicants. And essential prime implicant. What do you mean by essential prime implicant? Essential prime implicants are the prime implicants which can only cover a particular min term or max term, are known as essential prime implicants. So the prime implicants which can only cover a single min term or max term, no other group is covering such type of min term or max term, is said to be essential prime implicant. That means if any 1 or 0 is covered by only one group, and the prime implicant written for that group is said to be essential prime implicant. So a prime implicant is said to be essential prime implicant if it can cover a min term, if it can only cover a min term or max term in a K-map, is known as essential prime implicant. Now, what is don't care conditions? So we know that, so for every combinations, the output may not be specified. So that means, for example, if we have an invariable Boolean function, the number of possible input combinations are 2 power n. So for all the 2 power n combinations, the output may not be specified at either 0 or 1. And the combinations for which the output is not specified as either 0 or 1, such type of input conditions are said to be don't care conditions. So the input combinations for which the output is not specified as either 0 or 1, such type of combinations are said to be don't care conditions. Okay, so that is don't care condition. Define tabular method. What is tabular method? So tabular method was introduced by scientist named Quinn McCluskey, and this is nothing but a tabular method of simplifying the Boolean function. So whereas the K-map was the graphical method of simplifying a Boolean function, whereas tabular method is we are constructing a table which is used to simplify the Boolean function, that is known as tabular method, and it was developed by the Quinn McCluskey method, and hence we can also call it as Quinn McCluskey method or else QM method. Okay, so which we know that the prime implicant is product or sum term which cannot be further reduced by combining with any other sum terms or product terms of the given function. So if it is, so as in order to eliminate the limitations of K-map, we will be going for tabular method. So tabular method is the method of simplifying, one more method of simplifying the Boolean function by constructing a tabular form. Now, define a combinational logic circuit. A combinational logic circuit is a digital circuit which consists of logic gates in which the output depends only on the present input and does not depend on the present state of the circuit. So this is nothing but combinational circuit. Any digital circuit in which the output is a function of present input and it not at all depends on the present state of the circuit, or else the previous output of the circuit. Such type of digital circuits are said to be combinational circuits. And the examples for combinational logic circuits are adders, subtractors, and multiplexers, demultiplexers, encoders, decoders, and so on, in which the output depends only on the input applied at that particular instant of time. It won't depend on the previous inputs or previous outputs of the circuit, and it does not require any memory unit, and also no feedback is required in case of combinational logic circuit. So when such kind of definitions are asked, so you can have a block diagram like this: combinational logic circuit where we don't have any other circuits, like these are n inputs and these are the m output. Okay, so where we don't have any feedback and even memory element is not required, because the outputs are only the function of inputs. It does not depend on the previous outputs or else previous inputs. Now define half adder. So half adder is a combinational logic circuit which performs the addition of two binary numbers of single bit each and produces two outputs, sum and carry. So half adder is a combinational circuit which performs the addition of two binary numbers of single bit each and produces two outputs, that is sum and carry. Define binary adder. So it is also defined as the combinational logic circuit which performs the addition of two binary numbers of more than one bit each is known as binary adder. Now full adder. So how can we define a full adder? Full adder is a combinational logic circuit which can perform the addition of three binary numbers A, B and C where A and B are the two parallel significant bits and C is the carry input from the previous section. So in short, we can also define a full adder as a combinational circuit which can add 3 bits of data at a time. So this is nothing but a full adder, and while performing the addition of 3 bits of data at a time, it also produces two outputs, that is sum and carry. 1 bit sum and 1 bit carry. Now define a multiplexer. How can we define a multiplexer? Multiplexer is a combinational logic circuit that has 2 power n data inputs, n selection lines and a single output line, and one of these input lines will be selected based on the control lines or else selection lines, and the input will be sent to the or else connected to the single output line. So this is the multiplexer, and this is the logic or else graph block diagram for this one: 0, 1 and so on, 2 power n minus 1, and these are the selection input: 0, 1 and so on, n minus 1, and one output line. So this is 2 power n by 1 max. These are the selection inputs, and these are the data inputs. So 2 power n data inputs, n selection inputs and one output. So this is the multiplexer, right? Now coming to the demultiplexer, define a demultiplexer. So a demultiplexer is also a combinational circuit that performs the reverse operation of multiplexer, where it has single input line and 2 power n output lines, whereas n selection lines. So the n selection lines are used to select any one of the 2 power n output lines, and the input available on the single input will be sent to that particular selected output line. So this is demultiplexer. So multiplexer is known as data selector, where demultiplexer is known as data distributor. Why? Because it distributes the data among 2 power n outputs or else destinations. Okay. Now coming to the comparator, define a comparator. So comparator is an combinational logic circuit which can compare two binary numbers of more than 1 bit or more than 1 bit each and produces 3 types of outputs, whereas the outputs can be either A less than B or A greater than B or A equal to B. So this is a combinational logic circuit which can perform the compare the two binary numbers A and B that may have any number of bits, whereas it can produce three outputs, that is A greater than B or A less than B or A equal to B. This is the combinational, it is a comparator circuit block diagram. Now, code converter. What do you mean by code converter? So, code converter is also a combinational logic circuit which is used to convert one form of binary code into the another form. Is nothing but code converter. So, code converter is a logic circuit, combinational logic circuit, which can perform the conversion of one form of binary code into the other form of binary code. So, coding can be used for security purpose to protect the information from stealing and interrupting. So, we have to design these code converters while transmitting. So, if you convert these codes into some secret form, so that the stealing or interruption can be avoided. That means exact data can be retrieved by the receiver. So, this is how we can use the code converter. Now, parallel adder. So, what is a parallel adder? Parallel adder is an arithmetic combinational logic circuit that uses or else that is used to perform the addition of two binary numbers of one bit of more than one bit each, and the addition can be performed all the bits at a time. The addition of all the bits at a time is done parallelly, then that is called as parallel adder. Parallel adder is an arithmetic combinational logic circuit which performs the addition of two binary numbers of more than one bit each parallelly. That means all the bits of two numbers are added parallelly at a time. Such type of adders are said to be parallel adder. What are the applications of multiplexers and demultiplexers? So, the multiplexers and are used in the communication system to carry out the process of data transmission. So, majorly we can find the application for multiplexer and demultiplexer in communication in order to carry the data transmission. What are the limitations of K-map? So, here as we have K-map limitations with K-map, so we are going for the another method, that is Quine-McCluskey method. What are the limitations? So, the K-map does not necessarily used for the simplifying the Boolean functions which are having more than 6 bit each. Why? Because it becomes complicated to form the groups of adjacent cells. Even we can feel difficulty with the 6 variable K-map. So, up to 5 variable we can easily simplify the Boolean function. So, that is why we are not using this K-map for larger Boolean functions which is having more than 5 variables. So, that is the limitation of this K-map. What is the difficulty that we can find? Grouping is a difficulty. That means we could not be able to identify the proper adjacent cells such that all of them are grouped and we can get the more simplified expression. So, as this is the drawback, so we are going for the tabular method. Now, what is meant by corner map? So, as we have discussed it just now, K-map is a graphical method of simplifying the Boolean function. What are the applications of full adder? So, full adder is used in arithmetic logical unit processor chip to perform the arithmetic and logical operation. Even I can use the full adder in order to perform the subtraction also. What are the advantages of K-map? So, as we have seen that Boolean algebraic method of simplification is tedious and it does not have any systematic approach for simplifying the Boolean expression. We are going for the K-map method. So, minimizes the Boolean expression without the need of using various Boolean theorems and computation. This is the main application or advantage of K-map. And it minimizes the number of logic gates used also. So, these are the advantages of K-map. Next up. So, K-map is a graphical or else pictorial method of simplifying the Boolean function. What is magnitude comparator? It is again a combinational logic circuit which is used to compare two binary numbers of any bit of any number of bits and produces three outputs, that is checking whether the two numbers are equal or greater or less than. What are the applications of decoder? So the decoders are mainly used in circuits to convert instructions into CPU and control signals, and they are mainly used in logic circuits data transfer. So these are the applications of decoders. What are the disadvantages of K-map here? So it finds difficulty in simplifying the Boolean functions more than 5 variable, because the grouping becomes complicated, and we may not get the unique answer. The answer may not be unique because the grouping can be done in a number of ways. And what are the applications of encoder? So the encoders are mainly used to translate rotary or linear motion into a digital signal. That means where we are going to use convert the analog data into digital data, we'll be using encoders. Usually this is for the purpose of monitoring or controlling motion parameters such as the speed, rate, direction, and distance or position. So define the structure of K-map. So K-map is nothing but an array-like structure, or else is a grid shape in which we have two parent cells, and each cell represents one of the two parent input in one of the two parent possible input combinations of an n variable Boolean function. What are the applications of digital comparator? So the digital comparators are mainly used in analog to digital converters, that is ADC, and arithmetic logic modules, or else logic units, that is ALUs, to perform variety of arithmetic operations. So what is a digital comparator? Which is used to compare the two binary numbers of any bit each, and it can produce the three outputs, that is a greater than B, A equal to B, and A less than B. What are the applications of digital systems? So the digital systems are mainly finds application in communication and VLSI, and even in the designing of microprocessors and microcontrollers. So we can find so much of applications for digital system in our real life system. So these are some of the definitions and terminology on the third module, that is about the minimization of Boolean function. That's all for this lecture. I hope it is clear to you all. Just go through this so that you can understand what are the basic concepts and terminology related to the module 3. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.